Hello everybody, this is Charles Anderson. I'm just a guy from Goodwill, and I've got a really great video game idea. And this is in my, this is one of the appendices. It's an appendix to my main series, and I'm putting it in right before packages, because from the moment I finished my flow control, we're ready to start in on object-oriented programming. Okay, otherwise known as OOP. Oop. And so yes, this is just an appendix that covers the whole idea of object-oriented programming. So what is object-oriented programming? And of course I got my little oops. No, this is not oops. It's just oop. Object-oriented programming. Okay, so Java is one of these high-level programming languages. There's low-level. I guess medium level, which is a low level with some of the high level elements, but high level and low level is used in programming terms to refer to mm, how elegantly is it designed. I guess yes. I'll go with that for now. Java is one of these high level programming languages. Okay, C was the language C was one of the first, if not the first, object-oriented programming language. Now, low-level languages, in contrast, include assembler. That's where you're actually writing code on the chipset level. Uh, then there was like back in the day, Fortran, Basic, JCL. I guess COBOL was its next level up. And of course, it all based down to the soldering gun and vacuum tubes. Or well, we have a lot of things that were better than vacuum tubes, but ENIAC, the first really cool computer in existence, it used vacuum tubes to do the flow control. Have to start somewhere, right? So low-level languages just means this is down to the bricks and buttons for the physical devices that make up the things that we use. And then from there, we attach them to our high-level programming languages. So that's and Java is really cool because it's got these bytecodes which look like low-level, but because they're platform independent, you just say, okay, so these are the operations. Java Virtual Machine specification being, how you would write or solder your chipset to be able to, interpret Java bytecodes. But anyway, so object-oriented programming. Okay, it has one very big cool concept, and this concept is modularity. Okay, or being able to write something once, then reuse it again and again and again, in different programs. So yeah, it allows us to box up values and methods to work with those values to write it and then run it anywhere. So write once, run anywhere, or that's that's uh, that's object-oriented programming right there. Okay, so we know that every program has a place where it starts, and it runs until it's done. Okay, and for JMonkey Engine, come on. Do 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 do. Oh, and I got a bunch of stuff open here. Okay, so let me take off this breakpoint. Okay, so here's our good old Hello World example from the very first lesson. Okay, and the start of the program. Here's the start of the program, and here's the end of the program. When it reaches this point, the program's done. And yeah, that's the way that we see it in Java. And of course, back in the old school days, you just fired up your assembly language program or your basic program, and it would start at one point and then go to the end. Okay, and object-oriented programming notates the start of it by this right here, and this specifically is set with the compiler to say, okay, this is where the program starts. And so when this program's run by itself, well, this class, it's run by itself, then here's where it starts, and it runs through it. So, yeah. So it the old style just loaded up the whole program, right? And then it ran it. Well, Java does this too, in a way. And however, object-oriented programming, lets us break. Let me get back into my full screen. Pretty full screen. Yeah, it allows us to break up a program into objects that can be used on an as-needed basis. So, you got your class, got methods inside the class, and you don't need to use all of it. You just get it fired up, and it pulls in. The compiler pulls in what's the runtime environment, Java runtime environment. Pulls up the stuff that it needs and puts it into memory, and then goes and runs it. And as it needs to clarify stuff, it pulls that stuff in and runs it. There you go. So now we have a different type of memory model, because here it was just, hey, here's the memory that was in your computer. All right, and now computers these days, we say, okay, well, we just want a chunk of this memory, and we'll work on that. Okay, and so the computer now has a different memory model that lets us bring in these objects on an as-needed basis. So let's take a look at the Java memory model. It's got 4 sections: code, stack, static, and heap. And the code part is like this current, Java bytecode that's being run. It looks a lot like assembler, but it's a little bit different. Then we have a stack where it finds the method. Like, well, here, let me pull up a picture. I got a picture. Let's see here. Yeah, where's my picture? Ah, yes. PNG file. And here we go. And here's a picture, okay? And so the Java runtime environment makes this heap, okay? And inside the heap, it starts, allocating stuff. One of the 2 things that you can specify when firing up the Java runtime environment, in your Java program, is the stack size for that program, and then the heap size for the environment itself. So the stack goes, and I say thread here because your program is actually just a thread that the Java runtime environment starts, and I'll go into threads in that section. But so the stack, the way that this stack works is that you've got these things called frames, okay? Like this right here, from the start of the program to the end of the program, is the bottommost frame for this thread, okay? And so then we hear on system.out.println, when it runs this, it actually throws some other frames up on the stack too. You just don't see it. But they're small, and to show you what this looks like, we can actually start up a debug session. Okay, so here we are, and we're going to debug this. All right. Now, if I were just to, go right here. Here, let's look in our static section. We actually have the class itself, and right there, it's in the package beginner Java, and it's the beginner Java class. Okay. And, they have constructors and all that good stuff, and public met references, and, they got numbers and such. Yay. So, oops. But yeah, let's go here. And, so I'm looking for the one named main. Yeesh. Well, not going to worry about it. But anyway, let's go to step into, okay? Because right now we have this, okay? And once we step into it, yeah, here's what we know at this moment. Let's step into it. All right, so here's print line. This is the command that you activated, all right? and it's in a class print stream .java, and it's in the Java I/O section. Okay, and we have the string that was passed into it as x, right? And that was hello world. Okay, so this is synchronized. This has to do with threads. In other words, this stuff is locked. So from here to the end of this thing, this is locked down. All right, so we come in here, and of course, inside of print line is print. So we'll step into it one more time, and here's for print. Well, it checks and makes sure that the string's not null. If it is null, then it just, prints out null. Otherwise, it will call this function called write. Well, on this picture here, I only go 3 deep. It goes 4 deep because there's write, and then on top of the write, there's error checking in there, and so on and so forth. So the stack goes up as each one of these are gone into, and then when it's done with it, it pops it down. So for that little hello world, and I'll just go ahead and step over now. Bloop. And then just so that you can see what our output is. See, it just printed hello world. And now it's going to, because print line also prints a new line character, then it goes new line. Bloop. And then, see, now it's down to the next line. And then we're done with that. And then we're done with the program. And remember what I said about threads. Here's where it terminates this thread. And done. So look, it only took 3 minutes and 18 seconds to step through something, in a debug mode, where, it's just really not that much time at all. But that was just stepping into everything so that it could be seen. Whoops, there we are. So yeah, that's the stack right there. And so it's here in the heap, and then you've got some constants for the thread running, and of course the heap also contains area for dynamic stuff. So the hello world example, as we see from the code that we write, that's the .java file. It gets translated into codes that are ready to be read into a Java virtual machine. It's the .class, which you'll find in these jars that when you build, it makes these class files, and each class file corresponds to a public class. So yeah, your programs, it's a thread run from the Java runtime environment, and that's how you can think of it as. So yeah. So yeah, the static segment of memory that is shared for the whole program, for that, thread or program, I'll just say program, it gets loaded first. It stays constant for the whole program. There's just the idea behind that. So there's one copy. It's a constant, and it's accessible from the whole program. Heap, okay. This is the segment of memory that that holds instances. So like you can have a variable of like x and y for coordinate location inside of a class named point. Okay, and this is going to change every time that you use this class or an object of this class. So they get their own little storage locations individually in memory. And so this is dynamic memory versus the static concept right here. It gets loaded on a per instance basis, and when it's not being used anymore, then garbage collection happens. Memory's freed up. So that's that whole idea behind code, static, stack, and heap. Static and stack being contained within heap for that thread. Code? I don't know. Code's just the current line of bytecode that's being run and shipped off to the processor. It may be inside of the heap too. Not really that sure from my point of view. But of course, I don't really have to worry about the virtual machine because I'm just going to be coding a game, and I'll let the machine be taken out of care. Oh, objects. Okay, there's a class. It is called object, and that is not this. Okay, maybe these should be called modules. I'm not sure, but anyway, the objects that I see. All right, classes. I had to click. Classes, definitely objects. Okay. And possibly these other things. Packages, that's definitely the jar file. The packages that are within the jar file. I see packages as like folders inside of this jar file. So yeah, you got a folder, and it'll happen to have the name of your package, and you will find your classes and stuff, the .class files inside of these packages. But so packages, they can contain classes, interfaces, enumerations. Okay, and classes, well, they can contain methods, arrays, and variables, and other classes. Right. So packages can contain packages, classes, and classes can contain classes, methods, arrays, and variables. So, I tried to start from the top, work my way down. It makes better sense for me to work my way upwards. Looks like I'll be meeting in the middle for my presentation because classes are the big important thing. So classes are the big important thing. But inside of classes, the stuff that you're actually working with are inside of classes. So, go figure. I'm throwing in this appendix to help clarify. Alright, so this is JMonkey Engine. Well, I use JMonkey Engine. I use Java. My name's Charles Anderson. My project's Idiog. I've got an email. I've got a Twitter. And that ends it for this quick little presentation on object-oriented programming. And, of course, the rest of the series, this is technically supposed to be at the end of the series, but where I'm placing it at, the rest of the series will be clarifying object-oriented programming in action. All right, peace out, y'all.